In this video, I will introduce to you adding and subtracting rational expressions. So like we already know, rational expressions can be dealt with just like fractions. So to add or subtract rational expressions, just like with fractions, you have to have the same denominator. So just like with fractions, we're first going to determine a common denominator. Now the smallest one is best because that's going to save us some trouble with simplifying our final answer, but it's not absolutely necessary. Now, just remember that whatever you need to multiply each denominator by to get your common denominator, the numerator must also be multiplied by the exact same thing. And you have to do that for each expression until everything has the common denominator. Then you can add or subtract. Now, a quick example with fractions. I see that I have denominators of 5 and 4. Now, a common multiple between those would be 20. So I have to think, what would I multiply 5 by to get 20? And that would be 4. Now, if I just left it like this, 5 times 4 would be 20, but the numerator would still be 2, and that fraction is no longer the same. 2 over 20 is not the same as 2 over 5. So whatever I multiply the denominator by, I have to make sure that I do the same thing to the numerator. So that fraction will now become 8 over 20, which is equivalent to 2 over 5. Now I can do the same thing for the next fraction. So to turn 4 into 20, multiply by 5. But again, the same thing has to happen to the numerator. So that will become 15 over 20. Now I can just add up the numerator. So we don't actually add the denominator. What we're doing is we're adding 8 plus 15 is 23. We have 23 twentieths. Now, we're always going to look for fractions and rational expressions. Can we reduce that answer? No, we cannot. So we're done. All right. Now, with rational expressions, it's not always going to be that easy because our common denominator could just simply be a number, or it could be a variable, x, y, a, b, c. Could be a binomial or a trinomial. All right, so the denominators could contain anything at all, so we have to really be careful. Now, these first couple of examples, if we take a look at them, I'll zoom in a little bit here. We're going to simplify and state any restrictions. I actually already have the same denominator for both these examples, so 12x to the power 6 for the first one. We'll do the second one in class. Now, because they already have the same denominator, I don't have to do anything. I don't have to change them. All I can do is just add up the numerators. Now, just to show you for this lesson, this is something you might be able to kind of figure out without doing an extra step. But I'm going to write this as just one large expression. So x minus y plus, and we're adding x plus 3y. So just like when we were adding polynomials, I like to show this extra little step. Now I can see, okay, we have x plus x is 2x, minus y plus 3y will give us plus 2y, and that's over 12x to the power 6. So that's it. We've added them together. Now, our questions are always going to say simplify. We want to simplify our final answers as much as possible. So just like our very first lesson on rational expressions, I'm going to see if I can reduce this. Well, it looks like I can factor out a 2 from the numerator, and I'm left with x plus y. I can also factor a 2 out of the denominator, 6x to the power 6. And now because those are common factors, they will cancel out. So that will give me an answer of x plus y over 6x to the power 6. Now with that example, we already had the common denominator right at the very beginning. So let's take a look at number 3 here. Now, as you can see, we don't have common denominators, so we're going to have to figure that out ourselves. And then we're going to have to change each of these fractions so they have that common denominator. Now, between 4, 8, and 6, okay, all three have to have the same common denominator. You can pause the video and try to figure that out if you like. So what the common denominator is, it's 24. All three of these can multiply to 24. Now, you could use something bigger, but I'll always try to find the smallest one. So I would have to take this denominator 4, and it would have to be multiplied by 6 in order to give me that common denominator. Now that means that the numerator as well would also have to be multiplied by 6. So let's see what that becomes. That would be 18x plus 12 over 24. Now the next expression has a denominator of 8, so that gets multiplied by 3. The numerator would then also have to be multiplied by 3. So I'll be adding 3x minus 12 over 24. Lastly, 6 would have to be multiplied by 4, so the numerator as well. So I do like to show that I'm multiplying both the numerator and the denominator. It's always important to show all of our work. All right, so now we can write this all together as one large expression. So 24 is my denominator, and I'll use the same colors. I have 18x plus 12. I am adding 3x minus 12, but then I am subtracting 8x minus 4. So we have to be careful there because we're subtracting. Now, I'm going to extend this division. I'm not going to be lazy and stop it part way. All right, so now I can get my final answer. 18x plus 3x is 21x, but then I'm subtracting 8x, so I get 13x. Okay, so very important that we are subtracting that 8x there. Now we have 12 plus negative 12 is 0. Subtract negative 4. So we're actually adding 4 there over 24. Now, even with that example, it wasn't as complicated because we only had numbers or constants in the denominator. As you'll see in the rest of the lesson, we're going to have binomials. We're going to have trinomials even, eventually. There we go, in the denominator. So it's going to involve, again, our factoring abilities as well as multiplication and division.